I'm given a triangle ABC where side AC is 5 centimeters, side BC is 7 centimeters, and angle C is 42 degrees. Notice one of the sides doesn't have an opposite angle, and the other side doesn't have an opposite angle either. So I can't use the law of sines here. Because I don't have a right triangle, I can't use right triangle trig either. So I'm going to have to use something else. In this case, let's look at a triangle ABC where side A is opposite angle A, side B is opposite angle B, and side C is opposite angle C. The law of cosine is a variation of the Pythagorean theorem. So a squared is b squared plus c squared minus 2bc times cosine of a. Notice when you do the minus 2, the two things that follow, the bc, are the two things that are on the right. And cosine of angle A is the length of the side that's on the left side. So if I have b squared is a squared plus c squared minus 2ac times cosine of angle B. Now, at any given time, you're just going to use one of these. You don't have to know all three of them. But this just shows that depending on what side and what angle you're given, you can use a variation of any of them. So that is the law of cosines. Let's apply that. In example 1, I want to find the value of x. X is opposite the angle that's 35 degrees. So when I set it up, I have x squared is 9 squared plus 11 squared minus 2 times 9 times 11 times cosine of 35. Because 35 is opposite side x, the x is on the left and the 35 is on the right. And the adjacent sides to the angle that's 35 degrees wide are on the right. I can put the whole right side into the calculator and get 39.81, and then all that's left to do is take the square root of that, and I end up with x is 6.310 inches. Let's build on that. So now I have all three sides and I want to find the measure of angle theta. The nice thing about the law of cosines is often you just have to use it once, and then you can use something easier like the law of sines. So since I have the side that's 6.31 inches, and now I have the 35 degrees, I've got that pair, so I can use the law of sines. 6.31 divided by the sine of 35 is 11 divided by sine of theta. Cross multiply, isolate sine of theta by itself, and then take the inverse sine of that whole thing, and that gives you theta is 89.17 degrees. Example 3, now I want to find the value of theta. Different triangle. I have all three sides and none of the angles. So I want to find the side that's opposite the angle that I want to find. In this case, that's 9. 9 is opposite the theta. So 9 squared is 7 squared plus 11 squared. Again, setting up that Pythagorean theorem setup. Minus 2 times the 7 and the 11, both of those are on the right side, times cosine of theta. I'm going to multiply the 9 squared, the 11 squared, and the 7 squared, and get 81 is 49 plus 121 minus 154 cosine of theta. Now the common mistake here is just to take all three numbers on the right and combine them. So to say 49 plus 121 minus 154 is 16. The reason you can't do that is because the order of operations, the 154 is stuck with the cosine of theta. So I can combine the 49 and the 121, and I can bring them over to the left side, but that negative 154 has to stay with the cosine of theta until I'm ready to divide. So I go ahead and divide both sides by negative 154. The two negatives cancel one another, and I'm left with cosine of theta is 89 over 154. Now I'm finally in a position to take the inverse cosine of both sides. So theta is 54.7 degrees. Now if I wanted to find the other angles, if I wanted to find angle B and angle C, I would just use the law of sines. Actually, I would use the law of sines once and then subtract both of those angles from 180 and get my final angle. When do I use the law of cosines? Use it when you're given three sides of a triangle and none of the angles, or use it when you're given side angle sides, so two sides and the angle between them, but you don't have that pair to use the law of sines. So basically, use the law of cosines when you can't use right triangle trig and you can't use the law of sines.